you very much. So, okay, the slides are coming up. First, as it comes up, my thanks to DG Kalaisari ma'am and all the senior distinguished people, scientists and lab directors, department heads, and all the scientists who were kind to show me all your labs and explain to me very new terms that I was not very familiar with. And I hope to take that as homework after I go back to learn many of these new things. So again, it's a privilege to come here, and thank you for hosting me. So with that, I will, can you hear me clearly? It's just reverberating a little bit over here. Okay. Ah. Oh, that's why. Oh, okay, okay, very good, very good. Okay. Okay, so first I should acknowledge that everything I say here is quite a bit of a collaboration. As you can see, I've mentioned many people's names here, especially Srinivas Nagar, Dr. Srinivas Nagar, Pratima, Asta, lots of people. And okay, wonderful. And I've also mentioned that there are many others whom I have not mentioned. We also have collaborators from universities, not just in India, but across the world. And also our lab colleagues and Microsoft Research, both in India and in the Redmond lab. And we've also used open source contributions from the Microsoft Asia lab and so on. So this is a very, very collaborative endeavor. So everything you're going to hear about today will be of a few messages. One is from lab to market and how I'll give you a case study in the context of energy and clean energy and using AI, right? So I will be weaving a story that will tell you what we did, but also I will be weaving a story of how we did it, right? So hopefully it'll be interesting and it will not be just one-sided, okay? And this is a 2D barcode of my QR code of my LinkedIn. If you're interested, you can connect with me on LinkedIn and be very happy to catch up. Okay, so what I'll be talking about today is, so if you look at the lab to market as a journey from one end of the TRL or technology readiness level spectrum to the end of 1 to 9, you have basic or fundamental research on one end of the spectrum, and then translational research, and ultimately revenue and market type of metrics on the other end of the spectrum. So, so at the lower end of the spectrum, we work with the research labs, as part of Microsoft, as part of our external community, to write basic papers. We get raw code since we are a software company. We do all of those things, or we sometimes put open source code, or we pick up open source code that some other lab has done. In fact, I'll give you one of the examples where our Asia lab has put out some open source code. We picked that up. We actually then made it better internally, even though we did not directly collaborate with them, right? So in some sense, I'm using the good work that is done by some other lab, even though we may not directly collaborate in some cases. And then we have many universities we've worked with, including universities across the world. I'm remiss that I might have missed one or two of them. Also worked with Case Western University, others. We have had interns from different universities who come and spend time with us, and so on. We have in India, we have IIIT Hyderabad. We have, in the US, we have worked with CMU, UI, University, Illinois, Urbana-Champaign, and others. Right? So then what we do is we take this raw research output, which is probably TRL 1 to 3, maybe around 3 level, and then we convert that to applied research. Now, that is what we call energy AI frameworks. In our, I think the word frameworks means very different things to different people. I guess, Delhi circles, framework might mean different things. In our world, in software, framework is a set of code that it's almost like a platform. Like in a railway platform, you can go into different trains. So this framework is like a different train. It can enable many, many solutions. Rather than solving for one point solution, we try to capture patterns, and I call it Lego blocks or frameworks that bring two things together. It brings AI and technology on one side. It also brings use cases and ideas from the energy domain. So it brings a vertical flavor from the domain and customer and those sorts of things and those patterns, and then combines it or marries it with technology elements. And that combination is, you can think of as a Lego block or a framework element. And we allow each Lego block to work with others and so on. That gives us some catalytic or multiplier effect as we go. So you'll see in the applied part, that is one of the very important things we do. And this is very important because when I have worked on the product side of companies and so on, when we do product thinking, we think of what is called product market fit or a technology market fit, and you do an MVP or a minimum viable product, right? So sometimes people confuse MVP with a maximum unviable product, but we have to think of minimum viable product, and we have to make sure those things fit. And rather than doing point solutions, we have to have reusable componentry. So it's a subtle idea, but it's very important that we apply product-like thinking or platform-like thinking in this phase. And I will spend a lot of time in explaining examples of that. And finally, we also work with our colleagues who are what we call industry advisors and others to actually, and including sales colleagues of various kinds. We work with partners of Microsoft. We work with customers to do things. We jointly discover ideas. And so there is somewhat of a, managed, but somewhat, I would say, different. It can take different paths, right? Sometimes it will look messy, but every path is somewhat different. Every customer is different. Every pathway is different. Every partner is different. But now, at some point, you'll get some momentum, right? So once you start seeing these things used more and more, first it'll look like a bullock cart, then it'll look like like a motorcycle, then it'll look like a bullet train, right? So over time, it takes. So this is a journey from lab to market. So the message I want to leave you with is lab to market and technology transfer is not like tossing like like a volleyball on one side and you catch it and do something like that. But it's more of a collaborative effort. And the more you have people working very closely with each other at every step of the way, that is what leads to effectiveness, right? So I'll give you many examples of how we facilitate that and in our journey. Okay. And I'll be weaving through a story. So this is now I come back to the particular story that we have been working on, which is, as you know, if you want to address climate change, you have to reduce greenhouse gas emissions. And a significant fraction of greenhouse gas emissions can be attributed to energy of various sorts. Okay, it can be energy from transportation, energy from factories, energy from buildings or other forms of energy. Of course, there's other sectors like agriculture and so on. And it turns out that one of the major vectors of this is electrification of the demand side of energy. That is, you move from a car or a scooter, which is consuming fossil fuels to or burning fossil fuels, combusting that to an electric scooter or an electric car. So that's an example of electrification of that particular mode. Similarly, you can have electrification of a ship, or you can have electrification of a factory process. So electrification is on the demand side. Similarly, in the supply side, you can have a conversion of the supply sources to renewables, broadly defined. Renewables could also mean solar, wind, storage, hydro, any other forms like green hydrogen and other things, right? So the entire panoply of options. So that is now picking up a lot of momentum because the cost of all of these options are dramatically dropping very rapidly. And more importantly, all of them have been baked in with IoT sensors, which is now has created digitalization of all of these assets. Now we have technologies like cloud and AI that is coming in. So this allows us to orchestrate all these resources very well through various markets and so on. So what is happening is this whole space is becoming, even though you're dealing with physical assets, there is increasing role of digital, increasing role of AI in these areas. So that is essentially what I call this renewables area is moving from being cheaper to becoming smarter. So the last few decades, any particular renewable technology, especially solar, wind, and storage, you can see an incessant cost curve that has been happening. And it's been driven by a better technology, better supply chains, and more deployment. And that has led to faster and faster learning. And you've had consistent learning curves. Sometimes it's faster, sometimes it's slower. But and this has been quite consistent. And there is no sign that any of this is letting up, which means that this cheaper trend of all the key things is going to keep going. And especially areas like storage are in a cusp of real takeoff at this point. So storage and electric vehicles are at a point where you'll have mind-bogglingly high levels of deployment and again commensurately reduction in cost. So I think it's that S curve is growing really, really rapidly. And other supporting factors have been policy or finance that have been helping as well, right? So this has been the past trend. But going forward, you have to not only be cheaper, but also be smarter. What do I mean by that? It means that increasingly renewables, especially solar and wind, are quite volatile. That is, when the sun shines, only then solar will produce. When the wind blows, the wind will produce. But then solar, can be occluded by a cloud coming in between, and so you can have very large variations in production. And of course, the sun doesn't show up in the night. Similarly, wind can be quite volatile as well. And so this volatility wasn't a big deal when the total wind plus solar was a small fraction of the grid. But increasingly, as wind and solar become larger and larger fractions of the grid, and by mathematically, it means that the others will become a smaller fraction. What it means is that the others are no longer there to absorb the volatility that is being injected into the grid. So this is considered to be a self-limiting externality, to use a economist phrase. So if I have to handle the self-limiting externality, what that means is if you put out more renewables, the renewables will automatically limit itself. It will not allow more growth, right? Both economically as well as grid stability wise and all these things. So for that, you have to now start measuring demand, measuring supply, and matching demand and supply over all timescales, over timescales of milliseconds to seconds to hours to days, and especially in forward markets and things like that. Now, if you step back and ask, this is actually a data and AI problem and a software problem more than a hardware problem. So the game in renewables is shifting from being a pure hardware and cost reduction problem to also being a hardware plus software problem. Okay, so that's a key thing to remember. And the role of software and AI is going to increase, right? So that's why you'll be wondering, what is Microsoft doing in renewables, right? So then, why do we do these frameworks, energy or AI, right? So then we ask, how can I help accelerate energy transition using AI? So we have to remember, all technologies are in service of mankind. All technologies are to help accelerate something useful, right? Either you reduce costs or you have energy transition. So if in this particular case, how do I accelerate electrification? How do I accelerate, penetration of renewables? How do I accelerate markets to get created? How do I accelerate, entities there to become more profitable? Or how do I accelerate them to have, increase their return on capital, reduce their risk, right? So when you do these things, then it will incentivize more investment, right? If you ask any corporate person, they will ask two things. What is my return on capital? What is my risk, right? My risk determines my cost of capital. Return on capital will see what is my upside. Now, if my return on capital is high, cost of capital is low, this becomes an attractive opportunity to invest. So we are trying to structurally allow this to happen by using AI. So the purpose of AI is to help that. So then what we have determined is that if I want to do all this matching and so on, we have to first figure out what is demand, what is supply, how do I account for demand and supply and match it. So that is the blue building block called 24/7 real-time matching, right? So we have now a transactional infrastructure to do that. And then once you have a basic way of measuring and matching, the next question is, how much is my sun going to shine, in 24 hours ahead, or 1 hour ahead, 2 hours ahead, and 4 hours ahead, and so on, right? So this is a forecasting problem. Similarly, how much is my wind going to blow? Okay, and this is very important, because I think one thing people don't realize is, if you can forecast how much the sun is going to shine, and therefore 3 hours, 4 hours ahead, even 1.5 hours ahead, that is where a lot of money is going to be made, right, in solar, right? So increasingly, as you have more solar deployment, the ability to forecast well is going to be the difference between making money or losing money, right? So forecasting converts uncertainty to risk. And then once you have, you cannot eliminate uncertainty, you can only quantify it and have some ability to manage risk. And then once you have that, you have to be able to take decisions. You cannot be paralyzed by uncertainty. You have to be able to take decisions, and you have to take many, many, many decisions. You have to, then this decision making also will become autonomous. So AIs will start taking decisions, or agents will start taking decisions, what we call autonomous decision. Just like we have autonomous driving and so on, there will be lots of autonomous decision. And recently, everybody's worked up over DeepSeek and so on. It uses reinforcement learning. So similarly, we can use reinforcement learning to take decisions of matching demand supply. Typically, this is how to orchestrate demand, how to orchestrate supply, and so on and so forth. I'll give some examples of this. And then finally, how to use GenAI in various ways to increase the quality of interaction, with a remote operation center. How do I manage many, many solar farms, wind farms, and so on and so forth. And also use multimodal GenAI to dramatically lower the costs of managing these resources, right? So these are some examples. So this is the area, right? Now that is the what, right? I'll come back to keep jumping between what and how, right? So the way we operate is that if I look at the lab, we sort of reimagine the lab, right? So the teams that I mentioned are all co-located. So we have Microsoft Research India, and then we have a common canteen where we have breakfast and lunch and other things together. So the same teams like my CTO team and other development teams are in different floors. And so we are in the second and third floors. The Microsoft Research is in the first floor. So we meet each other in over breakfast. Every breakfast we have open conversations about the future of technology, where it's going, what's going. And I give talks in their area. They come and give us ideas. And so this common canteen is not only food for the stomach, but also food for thought that allows us to collaborate a lot. Right? I think this is very important. And then culturally, we treat each other as equals. Okay. Now, this is a very straightforward statement, but I find that many collaborations don't happen because some party is treated as a second-class citizen. Okay, I don't want to make it more bluntly than that, but the moment you do that, collaboration will stop, right? So first, you got to bring people together. Second is everybody is a leader, everybody is equal, right? So then, and the most important thing is how can we create value together? I think that is a very important thing. So all our colleagues who are in different parts of the organization, we treat them very equally, and everybody feels highly respected and part of the team, even though their roles are very different, right? So I think these are, I would say, two things. Of course, we also collaborate remotely with Redmond Lab in different ways, and Asia Lab and so on, right? So this is one message I want to say, how we reimagine labs. The second thing is, in some of my meetings with your colleagues today, I said that traditional publishing, you got to rethink, okay? So when we publish papers and patents and so on, right, we publish for a scientific community. That's very important, okay? We should not dilute that. I want to say that very importantly. But increasingly, I'm seeing that it is equally important for an individual researcher, each one of you who's a researcher, who's a scientist, to also build a personal brand and to, where appropriate, right, with your manager's consent, etc., also engage in social media. Okay, this could mean like writing blogs. It could mean, so creating short videos. And we were actually chatting about how we can have reels. Everybody knows how to make reels and YouTube shorts and so on. Increasingly, we can do those sorts of things. And I have realized that this is equally important, or if not more important, than the primary job of writing papers and so on, right? Because this allows you to democratize research and also popularize what you're doing. Okay, and also from a lab to market perspective, it also gives several opportunities for the rest of the market to know what you're doing. It gives a public accountability of this. So there are several benefits of this, right? So just to give you one concrete example, this was just a paper I was telling Kalaselvi ma'am that we wrote just came out 2 days earlier. Okay, this is just brand new or fresh off the press. So this was about how we use agentic AI or AI agents to generate diagrams. So AI can now you can specify text and get engineering diagrams as output, right? So just like you do ChatGPT and ask it to draw some picture, now you can ask this AI to develop a piping and instrumentation diagram, right? So this is focused on PNID diagrams, but you can use these techniques in other types of diagrams like electrical diagrams or other sorts of diagrams. So this is one thing. So interestingly, I just wrote a small blog, but what is interesting is that the entire blog was also written by AI. So what I did was I took the paper, gave it to ChatGPT, asked it to, I just asked it all kinds of prompt. What will, just taking the perspective of what a layman will want to ask, right? Then I took all the outputs, okay, put it together into an article, and my entire article was ready in 10 minutes. Okay, number one. Number two is there is a beautiful, sort of software, available from our friends at Google. It's called Notebook LM. Okay, if you don't know, please note it down, because this is a fantastic thing where you can submit a paper or just upload a paper, and then it will actually create a podcast for you. This podcast has 2 AI hosts. Okay, one man and one woman, I mean, talking in sort of American language or whatever, right? So they are actually discussing your paper, right? And they are discussing your paper as though they're ordinary people. And they make, sometimes when you listen to that podcast, you say, oh, wow, did I mean that, right? So it is, it's quite uplifting, right? So if you're interested, certainly, you can take a look at the recent, if you connect to me on my LinkedIn, there is this particular thing. So I've put a couple of things of the sort. Okay, the key point is now you can use AI to create social media. Okay, so essentially what I've done is I've taken my raw paper, which is a pure technical paper. Again, we're done with my colleagues, and submitted it to some AI. I've generated, sort of my article, which I wrote in 10, 15 minutes. I added this other thing, which totally took me less than half an hour to put together this whole thing. So imagine, like, every individual researcher can start popularizing their research. And guess what? This was done 2 days back, right? I did this thing yesterday morning, and today I already have between 4,000 and 5,000 views to this. So what has happened is suddenly your paper, imagine how many people read your paper, right? Suddenly now you have more people interested in it because you have more generalized it and made it useful to a larger audience, right? So this is very important, right? And so now what we're doing is we have done this for other things in the past. So we wrote a paper called Proof of Thought, and it is sort of one of the more fundamental things. The key thing here is that it was motivated by an applied problem, but we did a piece of work that was more fundamental in AI. So there is ideas called chain of thought and tree of thought, and proof of thought is motivated by the reliability requirements of this thing. So this means that even applied problems can motivate fundamental research. So, there is a, sort of a quadrant structure where they call this a pastures quadrant or use-inspired research. You can have use that can inspire fundamental research. So now what has happened is that the collaboration between our CTO office and our colleagues who are in the field trying to understand the problems has now led to a new fundamental research which we wouldn't have thought of unless we did that in the first place, right? So this is not applied research. It is applied motivating fundamental research, right? So that's the other dynamic which I think I wanted to mention. The third thing is this is due to my father, who actually runs a blog, and his blog is about temple and travels for temples, right? So he writes a blog on this, and he's close to age of 80, okay, and what he does is he takes his blog, then gives it to ChatGPT, and he gets the blog to write screenplays. And then he asks either ChatGPT or Google Translate or others to convert that screenplay into different languages. And then he uses another tool called Clipchamp to create videos, and he generates images for that using DALI 3. Okay. Now with this, he is able to convert his blog into YouTube videos and in Hindi, in Tamil, and so on and so forth, right? So what I'm trying to say is, if he can do it at the age of 80, I'm sure at our age we can easily sing. So I was just telling, AI is actually very easy to use. So you should not feel intimidated to use AI. In fact, it's very easy to use, and all is the only thing that is limiting you is your imagination on what you can do. If you can talk to anybody, you can use AI. Right? Now you can talk to AI in your own natural language. You can type it out in your own natural language. It is very polite. It'll never shout at you, it'll not get angry at you, and all that, right? So my request to you is, as scientists, please consider adopting AI. Okay. Now, of course, AI. This is for popularizing your research as well as this thing, because I think of social media as now becoming a first-class citizen in dissemination. So it is not just for another office to go and do that. I think each one of us as researchers and so on can do it as well. And now we can do it in many Indian languages. So we can indigenize. Now anybody in different languages can get access to CSIR research. People can understand your CSIR research in Hindi in their own language, right? And so on. These tools will only get better and better, or in Tamil or any other language. Right? So finally, just coming back to the story, right? So once we take this, this common collaboration, we take this lab research, okay, from the papers and the dissemination and all that stuff we do, into what we call building blocks. These building blocks are what are run by our CTO office. You can think of this as applied research, right? Sort of like TRL 427. And what we do is we take papers and fundamental work that has been done in the labs. For example, over here, this is a paper that I was co-author with our Redmond lab, Microsoft Research in Redmond. Collaborated with a whole bunch of us, and they originally did this work on forecasting. Okay, this is a forecasting technique using deep neural networks and so on. And they originally did this in the context of agriculture. They wanted to forecast, some parameters for agriculture like weather, rainfall and things like that. But then we said, hey, if you can do this for agriculture, why can't we use it for energy? So this is a thought that comes in the mind of somebody. So I think it is important to challenge each other and say, oh, even though we designed this for agriculture, why can't I pivot and use it in another area? So then we said, okay, I can go and solve a specific problem, like a solar forecasting problem or a wind forecasting problem. So we went and actually worked with one client or the other client, and now there is a lot of open source data available. There's a lot of solar data available, wind data. So as we did our initial work, we did that. Then we realized if I just do solar forecasting and then I have to do wind forecasting, then this is not very reusable, right? It becomes what are called point solutions. You have a problem, you have a solution, a problem, solution. It's not very scalable. Product thinking demands or platform thinking demands is how can you combine or synergize these various things, and can you come up with a block, okay, that can do any forecasting with a little bit of customization. So then what we did is we then put it all together and said we will take all the tools of different forecasting models that are available. We will create what is called a forecasting framework that with a little bit of adjustment or customization can be applied for demand forecasting, generation forecasting, solar, wind, price, any forecasting you want to do, right? So that's what we call a framework. Okay, the analogy I'm giving is like the Lego block, right? You can build any toy. The toy is like a solution to a problem, but the individual Lego blocks are the reusable building blocks. And if you notice Lego, they do it such that one block can connect to another block, and the block is quite flexible and reusable, right? So that's the idea. We actually, this is also a marrying of the customer feedback and what we want from the customer and what the technology can make together. So you combine market input and problem input with the technology input and together create a building block. And the constraint you place on that is it has to be reusable and it has to be lean, right? Lean meaning, see, whenever you go to market, sometimes as a researcher, we don't think about cost. Okay, we don't think of cost or economics as a first-class citizen. Okay, but when you are in my shoes or you're a CTO, you have to go to the industry. First thing the customer will ask, does it work? Second thing they'll ask is how many places has it worked before? Third thing they will ask is what is the cost? Okay. After it works, they'll ask what is the cost? I mean, of course, what is the value? After they finish, it's almost like you go to a market and you first say, okay, what is the brinjal? Okay, do you like it? And then you'll start bargaining, right? So it's almost like that, right? So first, so if you have to go to that journey, you have to navigate, and this is not quite easy. So I think it's important to the more Lego blocks you have, it becomes easy for sellers to sell this. Okay, that is the other thing. And also Microsoft as a platform company, we have to know that we are not a solutions company. We are not, like a point solution company. We are not a services company. So it is also important to understand your own identity of who you are and what you do in the market. So Microsoft comes up, doing this initially, but then we convert it into Lego blocks and we enable a whole bunch of partners, and they can go create solutions. They can go create end solutions. We make it easy, right? And we benefit because the more solutions there are, they will run on our infrastructure or cloud, and therefore we make our revenues, right? So that is the platform strategy. So the more you understand your own strategy, you're clear on what you should do. And more importantly, you're clear on what you should not do. And, you bring the what is called technology out and market in feedback, and have a reusable building block. So this is the part that's very difficult. Okay, to do this, you have to iterate, and do it many times. So as part of this, what we have done is over the last 3-4 years, we have come up with a collection of a few energy AI frameworks, some in forecasting and time series, some in making decisions, some in all these GenAI and so on. So what I'm going to do is in the remaining part of the talk, I'm going to give you some more ideas of all of this. So most important message is that it is not point solutions for point problems. It is a combination of the market input and the technology input. And this also gives an important lesson in lab to market. You can't just toss a technology and expect, right? It is called just like a startup does product market fit and MVP and so on. You have to iterate, right? You have to think of yourself as a startup operating in a market in a collaborative way. So that is the journey of doing that. And fundamentally, you have to, at the same time, technology is changing, right? Every 2 weeks, some new technology in AI pops up, and you have to make sure that your technology building blocks are So anyway, I talked about forecasting, so I'll not talk more about this, but the idea is that I can do many types of forecasting. And in addition to this, we also did a lot of software things. I don't want to spend too much time on software. Typically, what happens is building an AI model is only a small piece of the puzzle. There's a whole bunch of other things you need to get right so that the process is simplified, right? So what we've done is the AI frameworks not only gives you model choices, but it also makes the life easy, right? So we sort of bring a product mindset, even though we're not selling a product, right? So that's one of the things. So then what I've described so far is the journey from basic to applied. Now the next part is the very difficult part, which is finally, how do I scale it up to translation and customer and revenue impact and so on, right? So I told you, even those, those frameworks, we were not designed in an ivory tower. Okay, what happens is that we bring our customers to, these experience centers and so on, and we debate and discuss and whiteboard and say, okay, what are your problems? What can we do? Here are some building blocks. What can we do? So that every time we'll discover, and then we will then define co-innovation projects, and we have a structure for doing that. Okay, I'll describe how we do that. See, typically Microsoft on the left-hand side, right? We already have our products, right? We have, many of you might be using Word, PowerPoint, Excel. Those are all our basic products, right? Similarly, we have our cloud products, which are Azure and all those things, and Teams and so on. Some of you might be using. So think of these as foundational technologies. So customers can use this. They can buy it from our, blocks. It's almost like you go buy shampoo and whatever, right, from a retail store. It's like buying that. But increasingly, right, customers are coming to Microsoft and say, hey, you're Microsoft, you're a $3 trillion company. You tell me how to use AI, right? What is AI? I don't know what it is, right? What is this AI? What is digital transformation? This is my business. You help understand my business and you tell me what to do, right? So then what we do is we say, okay, look, we are not going to become GE, right? We are not going to become Siemens or so on, right? So we will work with some partners and build a partner ecosystem and say that, okay, together with GE or Siemens or TCS or Infosys, we will come together and solve your problem, right? So those are called co-building solutions, where the problem is very clear. The partners know what to do. We can do some consulting if required. We do high-end consulting with McKinsey or BCG, and then that goes to the next tier of service providers. Then we have partners who have, called ISVs, who have specific solutions, and then we make it happen on a cloud and so on. So that's called a partner ecosystem. Then the collaborative co-innovation is where the problem itself is poorly defined. The problem itself has to be discovered in a collaborative way, and you might do some workshopping and discover part of the problem. It's like an elephant. All of you are touching it from different parts. Some might be thinking there's a tail, some might be, but nobody knows it's an elephant, right? So there we will define a project called a co-innovation project. And both of us will agree that, look, we are taking some risk here. Okay, we will discover our way along. And then if it is of value, we'll have some milestones. And beyond that, we'll determine if it doesn't have value, we'll close the project or we will move on, right? So this particular method, we have a program in our energy thing. It was actually designed by my manager, who created something called an AI innovation office. So he used the CTO office, like which I lead, and our colleagues with the other engineering team and delivery teams. And then we put Microsoft Research to work behind us, because Microsoft Research as an entity cannot work directly with clients. And then we have extended ecosystems like industry partnerships with other industries, many other partners we can bring as co-innovation partners, universities, academia, and so on and so forth, and also open source communities, including the open source that Microsoft itself puts, or open source we draw from other open source. So we take all of that, repackage it, and then build it with the raw innovation and papers and other things. And then we actually become embedded with the client. So there is the AI stands for AI Innovation Office, but it's a construct that we jointly do with the client. The client brings some people from their side. So it's a very consultative approach and it has a governance board. It runs on an ongoing basis. And then this goes and talks to individual business units of the customer, right? So it's no longer about a chief, CIO or a CDO procuring some Teams licenses or office licenses. They're not buying some shampoos from us, right? They are asking how to transform their business, okay, or with AI, right? So this is, and this can succeed, this can fail, and so on, right? So as part of this, there may be some new areas where AI is not even tackled. Like, for example, one of our clients came and said, hey, I have all these diagrams, piping and instrumentation diagrams. Piping and instrumentation diagrams for engineers are like PowerPoint for consultants. Like consultants like to do PowerPoint charts and all of that. Whereas for engineers, we like to use this thing for all the processes, whether in various industrial. Now, can you inject AI into this and so on, right? So we took up that challenge. And now, after almost 6 months of work, you saw the paper that we published recently, right? And by the way, there were other things that we did in the middle. But now we have AI, which can generate diagrams, right? Earlier, we could have AI that can analyze diagrams. And then we flipped it around, so AI can generate diagrams. So AI can do two things. If you give me a complex document, it can analyze it. and it can summarize it and do other things. If you the other way is you give me a command, right? And then AI will generate something. That's why it's called generative AI, right? Anyway, so these are the kinds of things, but this delivers business value and you validate it. So then we have an engagement approach where it starts from envisioning opportunity and design. And so this you can say almost a very consultative process. But the key thing here is we combine what we call industry advisors who are very familiar with the industry and who have worked with many clients in the same industry, along with technologies like us. And then periodically we might also bring in researchers in that. And then we'll define an opportunity and decide how to go. Sometimes the opportunity is all innovation. So we'll use some of our frameworks and maybe we use some sort of a pre-production pilot and so on. Sometimes if we think that, okay, this problem is simple, you can just use existing products and so on, we will just say, hey, maybe we will partner with some other partner like Infosys or some other partner and then get it done quickly, right? So so that would be an off-the-shelf with off-the-shelf building blocks. So then it's very important not to over design for the solution. Not every problem is an innovations problem and not every. So this is an example of a process and triage we do. And after we even go through the whole thing, then what happens is, okay, now we've seen that the MVP is successful, then we have to scale it potentially. So then how to scale it and how to get people to adopt it. So there is sometimes we have an entire set of consulting partners who help in, sort of change management, adoption, execution excellence, and all these other things. So what I'm trying to say is as a innovation engine that CSIR is, you have to recognize, and this is something I learned when I was also a professor, I didn't realize this, the actual path to commercialization is very arduous. Okay, and there are many ways to fail and very few ways to succeed. Okay, so it's a long road. It has to be highly collaborative. It has to be a learning journey, and you have to realize that the technology is sometimes only 1% to 10% of the process. There is still 95% or 90 to 99% of work needs to be done. So I think that is one of the key realizations. And as I've shown you, it is a deep engagement that you have to do in all the steps. So once you do that, then you can get marvelous results. I can show you charts like this where we took forecasting. We went and worked with a client in US. They had 2 farms. We were able to have much better results than their current forecasting because they didn't use the latest techniques. So we could get a much tighter error distribution. And then because of that, that led to economic value, because we realize economic value is dependent upon the tails of the distributions and so on. Right? Once you understand that, that becomes a pattern of creating business value that you can replicate. So we took a core technology from one lab, but then we actually worked very hard throughout the process to make this work, right? And then notice that we did not do this in some ivory tower, right? We worked on real problems, real data with real clients, right? And this has real economic impact if successful, right? Worth hundreds of millions of dollars, right? So suddenly it's okay. So similarly, we've also done work on open source data. It also turns out there's lots and lots of open source data. See, sometimes you cannot share customer proprietary data with others as references, but you can actually take open data sources and so on. So I think CSIR can also become potentially a big contributor to open data sources for India and for the world, actually, in several of the physical sciences and so on. Okay. Then another area I want to mention is increasingly there are foundation models starting to pop up for various areas. Typically, when you apply AI, you can go and solve a point problem and say, I want to build a model for this, right? Now, the new way of doing AI is you just go to ChatGPT and ask a question. You're not actually building any model. So basically, in typical AI, there is something called a modeling or a training phase, followed by a inference phase or a question answering phase. So in the new world of generative AI, you already have trained a foundation model. You no longer have to train it. You just ask questions. Okay, in Tamil literature, I mean, there's a movie called Thiruvilayadal. There's one scene where they'll say, I know, because Kalaisari man will appreciate this. There'll be Kelvi na kekkaduma nee kekkariya. I mean, basically, you just have to ask questions, right? So the idea is that you don't have to, sort of train models anymore. So the time to value has been dramatically increased. So now, what is interesting is even for physics areas, scientific areas. That's why I wanted to highlight this here in CSIR and NPL for, now we have foundation models for weather forecasting, for atmospheric modeling. So what this means is the following. Typically, if you want to do weather forecasting, you actually have to run a high performance computing or a numerical simulation that takes a lot of time and compute. Now you can just run it as a forward pass of a GPU, which is directly modeled as a neural network. So what that means is this is 5,000 times faster and probably hundreds of times cheaper, right? Even if you consider the extra cost of a GPU and so on. use this to seed the forecast for any point in the world, right? So this is available now. For example, this is an area. This is also in open source, by the way. And not only Microsoft, there's Google has put something in open source. NVIDIA has put something in open source. Now there is a huge amount of open source foundation models popping up for science. Just last week, I've not included in the slides. There's a Matter Gen, which is another announcement from Microsoft, has been put out in open source. So for chemistry and other related material science problems. So I would encourage you to, especially, I know Kamakudi sir came and gave all of you a target of 25 Nobel Prizes. So if, this is a great way of actually, quickly bootstrapping, and the combination of AI in these areas can help you accelerate science and, hopefully accelerate your path to Nobel, right? So anyway, then we talked about forecasting and then taking decisions. So what we've done is we applied the same methodology towards optimizations, decision management, reinforcement learning, like all this DeepSeek kind of thing. Now we can now take combinations of solar, battery, wind, electrolyzers for green hydrogen. We can now model them as digital twins and then look at how do we orchestrate all these digital twins using AI embedded in that, and also optimization problems, right? All of this used to be very difficult modeling problems. What we have attempted to do is dramatically simplify it. So that way the paths to creating new solutions is lower. So if you notice, the value that the CTO office or generally our approach adds is not just give you raw techniques from the cloud, but it adds a layer of value without actually saying there's a point solution, right? So this is a general pattern. So now we can apply to specific problems like trading in markets, right? So today you have electricity markets, day-ahead markets, intraday markets, and other things in the electricity world. Now, increasingly, as you have renewables, you have to forecast and you'll have uncertainty. Under uncertainty, you have to determine how much of my capacity or potential production, which I have to commit to my day-ahead market, how much do I do to intraday markets? And then there is money at stake, right? So any mistake I make will be a penalty, right? So how do I do? These are called decisions under uncertainty problems, and this involves sequential optimization. Sorry, I'm throwing a lot of terms at you, but the idea is that these are complex optimization problems, but even this we have modularized so that this becomes a pattern with which you can build many, many, many solutions. So this single pattern can support literally hundreds of solutions, right? So more importantly for physics, as I mentioned, there are physics-based foundation models, but increasingly even for point problems, right? Like in oil and gas or carbon capture and storage, you have to model reservoirs and you have to model the dynamics of carbon plumes, going through underground reservoirs, and all of these are described by physics equations, PDEs, right? Any PDE now is increasingly you can model it directly as a neural operator. Okay, there are whole classes of neural operators. One of the popular class of neural operators from I think a lot of credit to Anima Anand Kumar and Caltech and several other colleagues from NVIDIA and so on. They originally came up with this and popularized this. This has been picked up by many labs and so on. This technology has been around only for about the last 4 years or so, 3-4 years, but now it's increasingly proliferating in several aspects of physics and science, right? So now as a national physics lab or national chemistry lab or any other science lab, please take this seriously, because AI is going to, if you use this, your path to success will be much, much faster. For example, we are expecting that these will be thousands or tens of thousands of times faster than running classic numerical simulations, right? And essentially, there's an approximation of a numerical simulation that you can do. Now, we have applied it to different problems, and we are now starting to go through that process. This is an example of a technology that we are still pushing through the process, right? We don't have a framework for this quite yet. We are working with initial customers. We are looking at their problems, trying to model that, and then building all the tooling that is necessary, and so on, right? And we have a global collaboration. We have collaboration with our colleagues in Ireland and Singapore, and so on and so forth. So different expertise comes together. I think the most important thing is to be ambitious, willing to take a risk. Okay, these are attributes that say that if something can change the game, anything that's 10x better, if something is 1000x better, you don't even have to think. Okay, you have to immediately go and use that. Otherwise, it's going to change your field before you know it, right? So it's important to drive in these areas. So we've also applied it to wind. For example, this is modeling the wind wake. Typically, what happens in these things, most of these simulations are used only for design or making a product and so on, but it's not used in operations. So, but now with these neural network models for physics, you can actually use this directly in your digital twins for operational decision making. So this can actually change the game where physics and things becomes a integral part. So if you're designing sort of a blade for a wind turbine, you can now start modeling it in real time and also optimizing it in real time, not just a single wind turbine, but also an entire fleet in this case, right? So this is an example of something which might be interesting to some of your labs. So finally, I'll just leave you with some thoughts in GenAI, where we are think of this GenAI as multimodal, right? Human, we have eyes, we have ears. Each of this is a mode with which we can understand the world, we can sense the world, and then we have to be able to understand and then collaborate and so on, right? So we have different techniques to be able to sense better, be able to interoperate better. So we have created some frameworks for it. Just to give you some sense, again, we have taken papers that have come out from research and we have created this thing. So one of the new frameworks we have taken is to use AI build AI agents, right? So this is it's a interesting play that today, if you look at data science, typically you would have to build a model, you have to test it, you have to do all this stuff, right? Now the new way of doing AI is the following: you just prompt, right? A prompt meaning you just give a say this: I'm a data scientist, this is what I want to do, and you say these are all my data sources. Now go build a model, right? Not just build a model, you take from millions of models that are already available, okay, in the open source or other things, and you build something called a task graph. This is like a workflow, and this workflow is actually automatically built by AI. Right? So we built a scheme with which we can do that, and then you have to go check it to make sure everything is fine. If you don't like something, you can change it. Then you press a button to deploy. So just to tell you, I used to take 6 months to build these things. Now this we can do it in 10 minutes. So you have to, whenever something like that happens, you have to take notice, because if AI can help you accelerate something, I think the value of GenAI in these sorts of tools is that it dramatically accelerates and gives you something that is reasonably good. So the importance of human is that now you can start doing things. It's not going to take away your job, but it will definitely, a human who doesn't understand AI is going to be replaced by a human who understands AI, right? So that thing that is important to understand. Okay, but now with this, I can now look at all these new buzzwords. We are very good at coming up with all kinds of buzzwords. We have AI agents and orchestration. So now, essentially, what I've done is I've made the entire process of creating solutions much, much, much faster. Okay, so you can now start, giving your commands, and then all you have to do is start becoming good in formulating the problem in your head, be able to interact with tools like this and do stuff. Now we also applied it to what are called multitask vision problems. So in this problem, this is an example of a health and safety problem that occurs in many asset-oriented industries. This is in oil and gas context, but we also have applied in renewables, where you are trying to see if some human is under a lifted load. Okay, that is the problem you want to solve. Why is this important? Because many of the deaths and injuries that are caused in these sites, almost 45% are caused by line of fire problems. And this is an example of a line of fire situation. Okay, this is the cause for a lot of things. As you can imagine, the moment I say that and say, okay, how can I solve it? Right? It turns out that the traditional way of solving it or building models doesn't work, because every time you build a model, if I go to a slightly different site, it will stop working. Right? Now with GenAI, you can actually create one model or use one model that tends to work in many places. But then you still have to figure out where is the human, where is the asset? Okay, is the human under the asset? You have to do something called depth detection. And then these are called, each one is called a task, right? And you have to do this. And think of each of these tasks as something called a workflow, right? I showed you the task graph before. First I have to detect where are the objects, which is the object of one type, what is the depth, this, that, right? And then you work this out. So when we did this for the first time, we actually built this manually. But remember what I told you, now we have created AI to do this faster, right? Now more complex problems can be done with AI helping you. So I think the general point I'm trying to make is that AI is not only helping you solve specific point problems, it is also going to help you solve more complex problems. So in other words, the target addressable market is going to become bigger and bigger. Anything earlier you just said it's impossible, now you can actually, it becomes tractable. So for example, there's another example from solar, another from energy example. You just give a picture, you ask AI to tell what's going on, and it can give you a detailed analysis of the anomalies. It can understand that this is a thermal image. Okay, it's not a RGB image. It's a thermal image. It is understanding that I'm dealing with solar panels. It is understanding that the red means something is wrong with that. Okay, and green means it's okay. And then it is also using its understanding to give you a deeper reasoning of what's going on. Right. So now we are having a new class of reasoning models that are coming out, where you can do deeper and deeper reasoning, right? So that is the additional thing. This I did a few months back. Now the same query, if I give now, it'll give an even more interesting answer. So similarly, I can go for wind. I can just give pictures of wind turbines. Earlier, I have to build a model for this. Now I can just ask, no modeling, right? Just ask, and it'll give me all kinds of things. I can also then create an agent with this and go forward, right? Anyway, so I'm just going to quickly wrap up. Like this, you can do a lot of things with documents. I don't want to bore you with all of mumbo jumbo, but you can handle complex tables. If you look at many of your documents that are coming out, you have complex tables. One of the things you have to think about as CSIR, as you put out more and more documents, public, if you make it in a simple way and you keep it open, AI can actually read all of them and it can find out market linkages for you or potential market linkages, right? So these are all newer things that can be done. And you can do complex tabular processing. We can process diagrams. I gave you some idea of generating PNID diagrams. Similarly, we've done a lot of work on analyzing PNID diagrams, analyzing tables, and so on and so forth. So these are all very hard pieces of work. Every client you have to slog through for the first time, but once you've done it, you then capture the patterns and then you make them reusable building blocks, right? Now you can put it into entire nice user interface. With a Japanese client, we did what is it called, a virtual reality called an industrial metaverse with the digital twins, enterprise knowledge. So you can put all of this and show off a lot of interesting things. But the key point is that now this becomes a collaborative problem-solving environment. Different customers might have different preferences. Some might want to deal with a mobile, some might want to deal with a more interesting virtual reality. All of this is the art of the possible, right? Okay, so finally, this is my last slide. Just in conclusion, right? We talked about the story of what I have done, but more importantly, I hope I've given you a sense of how we did it. Okay, and hope I convinced you that this is not volleyball or basketball throwing technology or transferring it across the one side to the other. Okay, so technology transfer or should be actually reframed. It should no longer be called technology transfer. You have to think of it as market creation or value chain creation, right? So it is actually you are actually trying to create a new market that doesn't exist today. Right? I think that is the way you have to think about it. And it's a very deeply consultative, very deeply collaborative. There's a lot of human elements, co-location elements, treating everybody equally and be willing to do several iterations. So the one who is going to be successful is the one who is going to do as many iterations as possible and willing to learn the fastest. Okay, and the compounding learning is going to determine success or failure. Right. So with that, I want to thank you and happy to take questions.
So we can take one or two quick questions. I think, do we have time? Yes, we have time. Yeah.
Yes. Please wait for the mic. Yes, if you can also introduce yourself, yeah, briefly.
I'm Dr. Vipin Shukla from CSIR. It's really very interesting to listen all these things because I have also some interest in technology forecasting and I did some work earlier. So whenever we did technology forecasting, definitely data is created or generated, or sometimes you store data from somewhere. So whenever we have to generate data, sometimes, as you said, that through workshops or experts' opinion or some sort of meetings, that is one way. And here, human intervention, human intelligence comes into picture. And another way of getting data is like data is generated through various mechanisms, but there is a question that how crude this data is and how to refine that data is. So definitely, again, human intervention, human intelligence is required. Second thing is doing modeling and then for doing forecasting. Now, third one is taking decision. Decision making is a process which is very important. Now, I just want to know that after you did modeling, you got some options, then how much human intelligence is important? And when I say human intelligence, it's not for an individual. It's in group or maybe in committee form or something, so that we can arrive at a better decision.
Yes. Yeah. Excellent question. I think let me break that down. You asked several pieces. So typically when we do a co-innovation project, you have to draw some boundaries around the project. Sometimes we might just do a forecasting project. Sometimes we might just do a decision project. Sometimes it might be slightly different. So every innovation project, you cannot overburden it with too many things. Otherwise, nothing will happen, right? So that's point number one. Point number two is, you correctly said, the goal is not to have a completely automated solution. You will never do that in an MVP, right? That's why it's called a minimum and viable and product, right? Minimum viable product is, it is minimum, it's not maximum, okay? And it's viable, not unviable, and then it's product. So that way it shows that there is a product market fit. You're trying to establish that, and you're trying to discover that, to be honest. Okay, so the goal is, once you discover that, then you make it efficient, right? So first time you're doing this in a co-innovation setting, your goal is to get to that. The third point I'll make, that was point number two. Point number three is that the end game is typically you have to redesign workflows or processes and so on, right? Because anything that is valuable is usually not just a product, but often it is a combination of things and humans, and it's effectively a process, right? You have a today an as-is way of doing things, and tomorrow you will have a to-be way of doing things, right? And we are trying to go the journey from the as-is to be, but still we are in the innovation phase. So what we tend to do is we try to figure out what the new workflow is going to look like and so on. Definitely there's going to be a human component, but the role of the human will change because AI can take over certain tasks, or all the componentry or the machinery that we put together will take. And then this allows something to scale up, right? Or it allows the quality to be better. For example, if I have a better forecasting algorithm, I was losing millions of dollars. Now I lose hundreds of thousands of dollars, right? It actually, you have a savings of some economic value. Then you can also scale it up, right? If I'm making more money, I can now scale it up so I can do many more things. So typically what happens is whenever something becomes efficient or you have ironed out all the kinks, then what you can do is you can scale it up. That actually grows the market. So when you grow the market, you may have the same amount of humans, but now they can address the larger things. That is what productivity means, right? The same input, you will create more value per worker. If I remember, Dr. Sridhar Vembu had come and talked about what is the value or revenue per worker, right? In his talk over here. So that is the way you can get to higher revenue per worker and more productivity. So that is the essence of that. Typically, technology as it gets adopted changes processes. Humans will be there in the process, but they will have different roles, and the target addressable market will tend to grow. Okay, it can't guarantee it will grow, but it will tend to grow.
LMs are available. There's a huge discussion whether a country should build its own or should go on whatever. So obviously, if you build your own and don't use AI, we'll lose the whole next 5 years or 7 years. So is that a good idea that someone starts using what is available and do whatever fine tuning and other stuff? Meanwhile, go ahead and do a back-end R&D to build your own, just like what DeepSeek and others have done. That's my first question. Second is, with the kind of AI tools that is easily available to general people, obviously you have the guys with malicious intention, and the kind of social media that we have today, this 2025 is definitely going to see a huge amount of GenAI based phishing and GenAI based all kinds of videos and negative propagandas and things like that. So do you think there will be a tool which will be coming in and work on a near real time by this social media to really find out that this is a generative stuff or a stuff which is generated and not a real one, so that it doesn't even come into the social media, because getting it back is impossible because it travels like lightning.
Yeah.
So you can't get it back. So what is it that that typically, especially Microsoft and so many other big giants are thinking about it? Otherwise, it'll have a severe damage for the.
Yes. No, okay. No, that's an excellent question. Again, it had many parts to it. Allow me to maybe break it up into 2 or 3 things, right? One is I'll just directly address the point, right? Now, there are increasing set of what I call watermarking technologies or responsible AI technologies that are complementing the actual AI foundation model, fine tuning, all of that. Okay. Now, in fact, one of the ideas I showed briefly was something called proof of thought. The idea of proof of thought is, when you have outputs of a large language model or an LLM, you can have some rules that are expressed in some domain-specific language or something like that. And we can actually prove whether the outputs are meeting that, okay, using some other technologies called theorem provers and so on. So that allows you to have more reliable or trustworthy outputs, right? So that is a class of technologies. I mean, this we happen to develop in our team working with Microsoft Research. That's just one example of a technology. But there are a whole other classes of technologies called watermarking technologies and responsible AI technologies and so on, right? So in other words, that itself is a subfield of AI that is growing rapidly alongside the other things that are coming in. So almost every company now has a department of responsible AI like Microsoft has and so on, which are working closely with all parts of the product teams, right? That's part one. The other part is regarding, okay, there are many LLMs, foundation models, India is developing and so on. See, as I mentioned, in all these AI, there's two parts: training or creating a foundation model, and then inference, which is actually just querying or like how you use ChatGPT or something. Now, what DeepSeek and some of the other techniques have shown us is that training a foundation model can be done cheaper than expected, right? So what this will lead to is when something becomes cheaper, everybody will start doing it. Okay, which means that you'll see a whole bunch of, already there are many people training foundation models, but now you're going to see 10x or 100x more foundation models to come. So I think so the trick is going to be, earlier the thought process was foundation model was so costly to do and only a few people can do it and so on. Yes, there'll be some big frontier models that will be of that kind. But there will also be smaller and smaller foundation models, which you can train it using a variety of techniques like reinforcement learning, distillation. There are a whole bunch of technologies there. So both training and inference are going to get cheaper and cheaper. Therefore, you can expect every country might want to have its own foundation model, or every discipline like physics might want to have its own foundation model, and so on and so forth, right? Like I showed you, there were foundation models for weather. Specific scientific disciplines, maybe you might want to have increasingly it's going to become again like foundations for accelerating certain fields. And there will also be other things for inference and solutions and those sorts of things, like the kind I sort of mentioned. So just to summarize, two parts. The specific concern about, there's a race between the bad actors and the good actors, and responsible AI and watermarking and all of that. Look, I think it's a field that is growing alongside. And then, the training and inference will continue to grow, right? See, this area is compounding so fast. And one of the things that humans struggle with is something that compounds very fast. Okay, so the only thing I can request you as a scientific or with its tables, text, diagrams. We also have done this for subsurface, all kinds of things. Now models can take and do something with it, right? So I would encourage you to start using that as an integral part, right? It's like a calculator that you use or whatever, right? So in your scientific pursuit. So if you're not using it, you'll fall behind in the global race. So I think that's my plea to folks who are more inclined. And just the same time, I want to assure you that if you know how to talk, adopting AI is a piece of cake, right? So we all know, as Indians, we all know how to talk. Right? So therefore, I have trust me.
Yeah, yeah.
Thanks for such nice lecture. Myself, Abdul, I'm from CSIR. So I have two questions regarding the downside and biases of the AI. So one is like how to mitigate the bias, because the AI is trained on the data and it generates the outputs based on those training data. So if we train to a political bias or something, any kinds of bias can be there. So the outputs will be biased to that we don't want in regular world information. Like on Google, there are, for example, two portals. One is biased to another party, one is biased to another party. We know that they are biased. But in AI, we cannot find those things. Yeah. The second is being a researcher. When I want to solve certain problems and I give a prompt to any AI, it will give me the result and the outputs based on the comma separated values calculations. That's all. That is the main engine of the AI. That is the weights. So based on the training, it is not solving it mathematically like we are solving on a regular basis. So, for example, if I have a mathematical problem or a kind of equation, when I write a code to solve this, it is based on certain structure, and it will do exactly the same. If I solve it 100 times, different equations, it will give me the same different solutions and correct solutions. But AI will not do that. It will just iterate over the next, what the next most probable word and output, and then based on that, it generates. So there is a risk. What is that risk, and how to mitigate those things being a researcher?
Okay. And then how do you solve problems? Okay, so bias again is also another dimension of responsible AI. Okay, so there are a whole bunch of responsible AI tools that can measure bias, that can mitigate bias, and that's another reason why India-focused AI foundation models are also being created, because it gives more weightage to Indian language content or our heritage and those sorts of things. So certainly, I think what will happen is any individual AI model can express certain things. But as you start having 1,000 flowers blooming, like the lavender fields that CSIR has developed for saying, so you can have 1,000 flowers blooming in terms of foundation models that can have different preferences. So you should expect that any individual model, you can certainly critique it for bias, but even though that will reduce, it will not be eliminated. So the only way is to have a more collection of models, and you use the model that is reasonably using. And by the way, AI will help you use the model, right? So we can actually, select from millions of models right now and automatically build solutions. Okay. So that's point number one. Point number two is AI doesn't give you answers or solutions for, like a scientific field like physics or others. That's actually not necessarily true. It is actually changing. It is correct that the original first models that came out were finding a lot of difficulty in solving elementary mathematical problems. AI also, if you give it, I'll give you another example. If you give it a meter, right, in your like an electricity meter, which has all these dials and so on, right? Most of the AIs get confused. They'll not know how to read it. Like a human can read it very easily, but the AI. So AI is all these funny failure modes. It'll behave like a PhD in many cases, but then it'll fail like an idiot in other cases, right? So that sort of catastrophic failure modes do exist. But that said, the more reinforcement learning or this more multi-loop, these O1 models from ChatGPT or these DeepSeek and so on, right? They have deeper reasoning capabilities. So there is another class of models called reasoning models, and Google has also put out another model which actually does a lot of analysis. It takes more time. This is called inference time compute. It takes more time in iterating through in the inference rather than just dumping the next word and so on. So those models tend to be better. I would say it's far, far better. And again, the only thing I would say is exponential improvement is very hard to fathom. What I saw 2 years back and now is like orders of magnitude better, right? Similarly, wait for 6 months, wait for 1 year, it'll become orders of magnitude. So the only thing you can bet on is you can always critique at any point in time, but do not fight the trend, right? The trend is like this, right? So that's why you've got to be, you've got to work with it, understand its limitations, but then see how you can use it usefully. Okay.
Fine.
If overdose of AI for one day.